Hello everyone, hope we got on okay with the previous part about plotting the coordinates and you've corrected your homework with the solutions that I have put up. Any questions, just email me. We're looking on page 438, the distance between 2 points. So this is the next section. So if you have your book out there in front of you, you can be reading it with me. A very useful measurement in coordinate geometry is the distance between 2 points or length of a line segment. In exercise 26.1, we used a graph to find the lengths of vertical and horizontal line segments. Graphs can only be used to measure distance if the 2 points can be joined by either a vertical or a horizontal line. So, for example, here is a vertical line. So you have 1 and 4. So this is at 1, that's 4. So we know the length is 3, the difference between 4 and 1. But if it's not a horizontal or vertical line, it's a slanted line, then you need to have a different method of getting the length of the line, and that's where we use this formula here. So the length PQ is equal to the square root of x2 minus x1 all to be squared plus y2 minus y1 all to be squared. And this formula does appear on page 18 of your formula and tables. So you will be given it in an exam situation. Okay, so if we look here at this first example, find the distance between A2, 1 and B3, 5. Now, they've done down here, they've written out x1, so your first x is 2. So I just write it over it. That pencil's not very sharp. So x1, y1, x2, y2. And then once you have that done, you always start off with writing out your formula. So you write that out first of all, and then you sub in. So for x2, you're putting in this your x2, 3. For x1, which is your 2, you're putting in there, all to be squared, plus your y2 is 5, minus your y1 is 1, so 5 minus 1. So 3 minus 2 is 1, so 1 to be squared, plus 5 minus 4, because we know in our BIDNAS we do the brackets first and the powers, is 4. So that'll give you 1 squared is 1, 4 squared is 16, so square root of 17. So the length of AB is the square root of 17, and you always leave it in root form unless they ask for it in decimal, because it's more accurate, because decimals can be rounded. Okay, then on to the next one. So again, you have your x1, y1, x2, y2. Write out our formula. D is equal to the square root of x2 minus x1 all to be squared plus y2 minus y1 all to be squared. Then we can simply sub in. So D is equal to the square root of x2 is 2 minus 1. Now when you have two minuses beside each other, you get a plus. So that would have been 2 minus 1, or you can simply write it as 2 plus 1. Then we have y2 minus y1. So y2 is 5 minus 1. So 2 plus 1 is 3. 5 minus 1 is 4. 3 squared is 9. 4 squared is 16. Add them together to square root of 25. And we know the square root of 25 is 5. Okay, so the length of AB, and it's very important you have these lines here, which mean the length is equal to 5. Okay, so now we're going to go to our exercises, and we're going to find the first one here on 26.2. Find the distance between the following pairs of points. Okay, so we're going to go and do the first one first there, which is 1, 2, and 5, 5. So the first thing I'm going to do is label them. So I've got x1, y1, x2, y2. Okay, then I'm going to write down my formula. D for distance is equal to the square root of x2 minus x1 all to be squared plus y2 minus y1 all to be squared. Now I'm simply going to fill in. So the d is equal to, my x2 is 5 minus 1 all to be squared, plus y2 is 5, y1 is 1, sorry, y1 is 2, so minus 2 all to be squared. So d is equal to the square root of 5 minus 1 is 4 squared, plus 5 minus 3 is 3 squared. So the distance is equal to 16 plus 9. Add them together to get 25. So d is equal to 5. And then to finish it off, our little therefore sign. In maths we can use for therefore. Oh no, they didn't give us names of it, so we can just leave it at d is equal to 5. It didn't give us the name of the line. Okay, now on to the next one. So I've done one from there. Now I'll do one from down here. So this is 2 part 1, and we have minus 1, 5, and 4, 6, and I'm writing them in there. So this is my x1, y1, x2, y2. Right, first thing we do, write out the formula. D is equal to x2 minus x1 all to be squared plus y2 minus y1 all to be squared. Now we're going to fill it in, replacing the x and y values. So x2 is 4, minus x1 is minus 1, all to be squared, plus y2 is 6, minus y1, which is 5, all to be squared. D is equal to, now 2 minuses beside each other gives us a plus. That's going to be 4 plus 1 all to be squared, plus 1 all to be squared. So D is equal to 4 plus 1 is 5, plus 1 squared is 1. Now we have to square this. So D is equal to 25 plus 1. D is equal to 26. And it doesn't have a square that we know. It would be decimal, so we just leave it as D is equal to square root of 26. Okay, so what I'm going to get you to do now is I want you to do question 1, 2, 3, and 4. Okay, so I've done part 1 and part 1 there. So it's the rest of question 1, rest of question 2, question 3, and question 4. Okay, so, and I'll put up the solutions tomorrow. So make sure you go back over this video. If you're stuck, any questions, email me. Okay, bye-bye.